It's 3:17 in the morning. Your phone starts vibrating, not once, not twice, but continuously. You don't even need to look at the screen. You already know something has gone wrong. You rush to your laptop. VPN connects. Your monitoring dashboard is glowing bright red. Hundreds of alerts, CPU alerts, database alerts, application alerts, network alerts, storage alerts, authentication failures, API timeouts. Every monitoring tool in your organization is screaming at you simultaneously. Within 10 minutes, someone starts an incident bridge. The network engineer insists the network is healthy. The database administrator says all queries are executing normally. The cloud engineer blames Kubernetes. The application owner believes it's the firewall. Meanwhile, customers can't log in. Transactions are failing. Executives are asking for updates every 5 minutes. And every minute this continues, the company is losing thousands of dollars. Here's the uncomfortable truth. This isn't unusual anymore. It's becoming the normal operating model for modern IT. Today's infrastructure is simply too large, too dynamic, and too interconnected for humans to understand everything in real time. Which is exactly why one term has suddenly appeared in almost every technology conference, every Gartner report, every CIO strategy meeting, and every vendor presentation. AIOps. Some people call it the future of IT operations. Others dismiss it as another marketing buzzword. So who's right? Today, we're going to separate the hype from reality. No vendor sales pitch. No complicated mathematics. No artificial intelligence jargon. Just a practical explanation of what AI ops really is, why enterprises are investing billions into it, and whether your organization actually needs it. Let's begin. Let's travel back about 15 years. Managing IT infrastructure used to be surprisingly straightforward. Most companies had physical servers sitting inside one or two data centers. Applications were monolithic. Network paths were predictable. Infrastructure changed maybe once every few weeks. Monitoring was simple. If CPU exceeded 90%, raise an alert. If memory crossed 80%, raise another alert. If a server stopped responding, send an email. Life wasn't perfect, but it was manageable. Then everything changed. Cloud computing arrived. Virtualization exploded. Containers became mainstream. Microservices replaced monolithic applications. Today, one customer request might travel through 30 different services before completing. It might start inside a web browser, move through a CDN, enter an API gateway, hit Kubernetes, call 6 microservices, query 3 databases, access a Redis cache, send a Kafka message, and finally return a response. All within 2 seconds. Now imagine one tiny component slowing down, not failing, just slowing down. That tiny delay propagates through every dependent service. Suddenly, one issue creates hundreds of symptoms. Your monitoring platform doesn't understand dependency. It simply reports everything it sees. One failed switch becomes 200 alerts. One overloaded database becomes 500 alarms. One DNS issue becomes thousands of notifications. This phenomenon has a name: alert storms. And alert storms are silently destroying productivity inside IT operations. Studies consistently show that modern enterprise environments generate hundreds of thousands of telemetry events every single day. No engineer, no matter how experienced, can manually investigate that volume of information. Eventually, something dangerous happens. People stop trusting alerts. They assume it's probably another false positive. This is called alert fatigue. Ironically, the more monitoring tools organizations deploy, the less visibility they actually gain, because signal becomes buried underneath noise. Hiring more engineers doesn't solve this problem. Adding another dashboard doesn't solve this problem. Buying another monitoring tool often makes it even worse. The industry needed something fundamentally different, something capable of understanding relationships instead of individual alerts. That solution became known as AIOps. The term AIOps was introduced by Gartner several years ago. Unfortunately, it quickly became one of the most abused buzzwords in enterprise technology. Today, almost every monitoring vendor claims they provide AIOps, but many simply added a few machine learning features, changed the marketing, and doubled the price. So let's simplify it. Forget every vendor presentation you've ever seen. Imagine you're responsible for traffic control at the world's busiest airport. Thousands of aircraft, different airlines, different destinations, different weather conditions, unexpected emergencies. Now imagine every pilot is talking simultaneously. If you tried listening to every radio conversation individually, you'd fail. Instead, air traffic control systems combine information, prioritize risk, understand relationships, predict conflicts, recommend actions. AI Ops does exactly the same thing for IT operations. Instead of airplanes, it monitors applications. Instead of pilots, it monitors infrastructure. Instead of weather, it watches performance metrics. Instead of runways, it understands service dependencies. Its job isn't simply collecting data. Its real purpose is helping humans understand what actually matters. Think of AI Ops as having three major responsibilities. Responsibility 1: collect everything. Logs, metrics, traces, network events, cloud telemetry, application logs, database statistics, incidents, change requests, even deployment history. Because an AI system can only identify patterns if it has enough context. Responsibility 2: understand relationships. This is where machine learning begins. Instead of asking, "Is CPU high?" it asks, "Why is CPU high? Has this happened before? What changed 5 minutes earlier? What systems depend on this server? Is this normal for Monday morning?" That's a completely different level of intelligence. Responsibility 3: take action. This is the biggest difference between monitoring and AI ops. Traditional monitoring tells you something happened. AI ops helps determine what caused it, who should respond, what should happen next, which runbook to execute, and whether automation can safely resolve it. Some mature organizations even allow AI ops platforms to restart failed services automatically before customers notice anything. That's where the real value begins. But here's the fascinating part. We've talked about what AI ops does. We haven't talked about how it actually thinks. Can software really identify problems before experienced engineers can? Can AI distinguish between a genuine outage and just another noisy alert? The answer lies inside the machine learning models powering modern AI ops platforms. And that's exactly what we'll explore next. For informative videos like this, like, subscribe, and hit the bell icon. See you in the next video.